Hello guys, welcome back. Very good evening from Cheenta Statistics Analytics Department. And yep, so I hope everything is going fine. Yeah. So yes, let's welcome back to today's problem. And this problem is really easy, super easy. So it's like a doubt from one of our students, and but this like really means like how do we write down the solutions with the logic. That is also really important. So we will kind of understand this, and it's a very easy problem, very easy to do problem, guys. So I think you will be able to understand that very swiftly. So and the solution is really easy also. So if you have not solved this problem before, like pause the video and then I think you can go ahead to the solution aspect after doing it yourself. So let's get started, guys, without further ado. So it's asked between like you have to find the relationship. It's told that the correlation between x and y to random variables is rho, and the minimum value of this over all values of a. So how to find the minimum value of something? So it's a function of a, right? So you have to find a minimum value of a function, it's a function of a. Find a minimum value of a function by differentiating it. Okay, it's a continuous function, differentiable function. So we'll see why is that so. And also it asks that the values of given by what. So we will see that what it comes out to be, but usually it will be like it's required to do it in terms of, I have not written that, in terms of rho and variance of x and variance of y. You have to find the solution in terms of rho, variance of x, and variance of y. That is the plan as of now. Okay, and that is how we will proceed towards. It's a very easy problem. So now it's told that the variance of what, y minus ax. So this is a function of a, because a and x and y are like fixed random variables, so their variance is also fixed. So it's written as by the property of the variance, it's y plus a square variance of x minus twice a covariance of x and y. Okay, how do we do that? We prove that by using covariance of y minus ax comma y minus ax. Using that we get this value. So understand, variance of a and variance of x are fixed, covariance of x and y is also fixed. So all these are fixed, and in fact this is a quadratic function of a quadratic function of a, and you can understand the quadratic function as positive like non-negative coordinate, like non-negative coefficient. So it must be looking like this, okay, not upside down, because as a goes to infinity and a goes to minus infinity, both of them will go to infinity. So therefore this looks like positive half and like a cup, and therefore minimum must exist. And since the minimum must exist, you can understand that let's just do the like the function of a. So let's just do the different, how to find the minimum. We do the differentiation of a. F dash of a is equal to 0. So how do we get it? We get that twice a variance of x minus twice covariance of xy is equal to 0. So we get that a is equal to covariance of xy by variance of x. So now, but remember, we need to find the solution in terms of rho and variance of x and y. So we write this as rho into root over variance of y by root over variance of x. Okay, why? Because rho is equal to covariance of xy by root over variance of x times variance of y. So therefore, we get this form. And let's understand this, that f of a was variance of a y plus a square variance of x minus twice a covariance of xy. So we need to write in terms of variance of a and variance of x and rho. So we write it as variance of y plus a square variance of x minus twice. So 2 covariance can be written as a times rho times root over variance of x times root over variance of y. So you have to express everything in terms of this covariance and this variance, okay, and rho. Now we have seen the minimum occurs at a star is equal to covariance of xy, like sorry, it turns out in terms of rho, okay, rho variance of y by variance of x, root over variance of y by root over variance of x. Okay, we have found that in these terms, and let's replace that over here. So the minimum value will be happening at f of a star, and it will turn out to be variance of y plus rho square variance of y, sorry, y plus rho square variance of y by variance of x times variance of x. This is the a square part, plus sorry, minus twice a star is replaced by rho square root over variance of y. So variance of x and variance of y will get cancelled, so we get just variance of y. And if we just calculate this, you will get that variance of y plus rho square variance of y minus twice rho square variance of y. So we get 1 minus rho square of variance of y. So this is a very easy solution, guys. So to know like the minimum, this is a very basic understanding. It requires basic calculus, so you must be good with this at least. It's a very easy problem. Okay, guys. So I hope you enjoyed that. I hope like it clears you basic much like it's a very much basic way. But yeah, one way to understand the depth of this problem is to like extend this problem. Like, what if you have multiple variables over here? Okay, a and b, a y minus ax minus az minus bz. Okay, so how will you minimize that? So that will require your multivariable calculus knowledge. Okay, that is super important also. So, and also can you like, I mean like, can you understand why this a is equal to this like 1 minus rho square into, like, what happens, why is this like 1 minus rho square into variance y? What happens if x and y has like x and y has, like, what if rho is equal to 1? Rho is equal to 1 ke liye a is equal to 0, right? So sorry, rho is equal to 1 ke liye a is equal to 0. So understand this. Rho square is equal to 1 ke liye the minimum value is 0. Why? Let's try to understand this. Why rho square is equal to 1 ke liye minimum value is 0? So rho square is equal to 1 ke liye kya hoga? Rho square is equal to 1 ke liye x and y will be linearly related. Okay, and a is such a point where therefore we are trying to find, if you see a will turn out to be that point such that y is equal to some that linear combination of a. I mean, y must be equal to ax, since like, if so, what I'm telling you is the following. What if rho is equal to, rho square is equal to 1? Rho square is equal to 1 means that rho is equal to plus minus 1. That means what? That means y must be equal to some alpha into x, right? Okay, plus beta, alpha x plus beta. Okay, some alpha x plus beta, some alpha and x, because they are linearly related, and therefore we take a to be that alpha only. So you get variance of y minus alpha x. So we get a, and the minimum must be at a, which is equal to variance of beta, which is a constant, and therefore it's 0. So we get that therefore for rho is equal, rho square is equal to 1, we get that its minimum is coming out to be 0 only, and it's an if and only if condition, which is really important to understand. See, it's an insightful problem. It gives you an insight about the problem. So whenever you have easy problem, don't just stop there, guys. You just explore the problem, and that's what will make you a better learner. Number one, better problem solver, and of course will like help you like make your own problems, understanding much more like depth. Okay, so all the best, guys. I hope you enjoyed the problems, and if you want to do more problems, more in-depth problems, to follow like this channel, and let's get, like, we do solve a problem a day to help you make your habit about problem solving every day, which is super important. Habits are super important. If you have read the book of Atomic Habits by James Clear, you must be knowing that how habits are, how small tiny habits are really important. And also, if you're looking for some crash courses, guys, for enhancing your skills in for the IIT Jam MS 2022, like check out our crash courses below. Okay, in the description, and I hope you will enjoy that. So like, subscribe, share with your friends who are also preparing, and to your juniors if you're just like watching this, so that they can, like, we all can grow together, guys. Okay, so bye bye, stay tuned and stay blessed. I will see you in the next video.